Hello, this is Eduardo Suarez. This video is going to be a continuation of my previous video, KAREL Programming Data Types Part 1. In Part 1, I explained two of the KAREL data types, user-defined structures and user-defined data types. In this video, we're going to put everything together in a practical application. I'm not going to go into details of what I have explained in Part 1, so this video is going to be a lot shorter. Let's get started. Here I have a work cell that I have already created. I have two tables. I call table 1 to the table on the right and table 2 to the table on the left. On table 1, I have defined a user frame with the X and the Y axis on the plane of the surface of the table, and I have an array of parts that are equally distant between each other. You will notice that the part array is 3 by 4, and I called rows 1 to 3 on the x-axis direction and columns 1 to 4 on the y-axis direction of the user frame. The first part is placed 100 millimeters from the x-axis and 100 millimeters from the y-axis, and the parts are 100 millimeters apart from each other. On table 2, I have also defined a user frame, and the part is located on the center of the table. Let's run this application. The row is going to pick up one part at a time from table 1, and it's going to place it on table 2, and then it's going to pick it up from table 2 and put it back on table 1. You will notice that the robot is picking up the parts in a predefined order, following row 1 to 3 from column 1, and then sequentially from columns 2, 3, and 4. So if I want to change the order of the sequence, let's say I just want to pick up one particular part from the array, that wouldn't be possible with this program. So let's stop this simulation, and we're going to create a new program logic. We're going to go to Files, and here I have already created two KAREL programs. The first KAREL program is called Part Data Structure. In the declaration section of the program, I have declared two constants using the constant instruction, and this is going to be the number of rows and the number of columns of the part array. Following that, I'm going to declare the user-defined structure, and I'm going to call it structure part data. Each one of the fields of the structure represents the position in the direction of each one of the axes X, Y, and Z of the user frame for table 1. Also inside type, I have declared another user-defined data type called part array. That is an array of the previously defined structure part data. You will notice that this is a two-dimensional array. The first element of the array is the number of rows, and the second element of the array is the number of columns. Once we have declared the user-defined data types, we can create new variables using these user-defined data types. in this case, I have declared a variable called part that is type part array, and I have declared another variable called select part that is type structure part data. So now in the executed section of the program, I can assign a value to each one of the elements of the part array. So what I'm doing here is assigning a position in millimeters on the X, Y, and Z direction of each one of the elements of the part. And also I'm assigning a number from 1 to 12 to each one of the parts. And that's all I have for on this KAREL program. Notice that I have declared the variable select part, but I haven't used it yet. We're going to save this program and we're going to build it. We're going to open now the second KAREL program. I call it select part. In this program, I have declared a new constant, number of parts, that represents the total number of parts of the array. On the type declaration section of the program, I have declared structure part data and part array, and on the variable declaration section, I have part and select part from part data structure. I have pick part position, that is type positional data type. I have row counts and column counts, that is going to be the counter for the four loops, and I have a more miscellaneous variables in here that we're going to see in a moment how they are used. On the executed section of the program, the first thing we're going to do, we're going to read the register number 4, and on register number 4, we're going to put the part number that we want to select. If we open the teach pendant, if we go to registers, we're going to see here in register number 4, that is going to be the part that we want to select. We're going to notice that the register is an integer. So one of the things that we're going to do, we're going to check that the register is an integer. If the register is an integer, the flag is going to be false. And also we're going to check that the value is between 1 and number of parts, that in this case is the total number of parts of 12. Then, if all these conditions are true, we are going to assign the integer value from the register 4 to select part number. The next thing we're going to do, we're going to initialize the data for select part position on the X, Y, and Z axis. So the next thing is going to be the two for loops. One is going to be searching through the columns from 1 to the total number of columns. In this case, it's going to be 4. And inside this for loop, there is another for loop that's going to search for the row count from row number 1 to the number of rows, and in this case is number 3. So what are we going to be doing? We're going to search for the part in the array whose part number matches the part we want to select that we got already from register number 4. Once we find the part, what we're going to do, we're going to assign the position on the X, Y, and Z axis to the selected part position X, Y, and Z. Finally, we're going to read the position register number 2. If we go back to the pitch pendant, and this time we go to position registers, we're going to see that there is a position register number 2, that is the position of the part on table 1, and we have position register number 3, that is the position on the part on table 2. Just remember that these position registers are taught on the user frame for the table 1 and the user frame for table 2. So if we want to get the data for the position, and also we want to get the yaw, pitch, and row, and the configuration for the position register according to the user frame for table 1, the best way to do that is just read the register and place it on the pick part position. That pick part position is a positional data type. So now the only thing that we need to do, we need to set the X, Y, and Z elements following the assignment that we have from the select part position X, Y, and Z. And we're gonna write the position register number 2 back with this information. So the first thing we do, we read it, we update the position on the X, Y, and Z, and then we write it back. So now we're going to save it and we're going to build it. Now we're going to get ready to run the program. We're going to select the teach pendant program main select position. You're going to see here that the first thing I do, and I'm going to define the user frame, the user tool, the payload, and the override. Then I send the robot to home, call the KAREL program part structure. I call the program, select part, and then I'm going to call the two programs, table 1 to table 2 version 2 and table 2 to table 1 version 2. We're going to go inside the teach pendant program, table 1 to table 2. What this program is going to do is the robot is going to pick up the part from table 1 and place it on table 2. So first thing we're going to update the user frame to table 1. The user tool is going to be number 1, and also I update the payload. Then we're going to do motion instruction linear using the position register number 2 with an tool offset predefined that's given by the position register number 5. We can see the position registers if we go to data and position register number 5. What they have in there is just an offset on the Z axis of 100 millimeters. Then it's going to be another motion instruction that goes to position register 2. That is going to be the position for the part. I'm going to call the simulation program that picks up the part from table 1. We're going to wait 100 milliseconds, and then we're going to go back to the previous position. That was be like a perch position with the offset of 100 millimeters on the z-axis, and then we're going to continue going to home, and I'm going to change the user frame to number 0. We're going to call home, and then we change the user frame to number 2. That will be the user frame for table number 2, and we're going to repeat exactly the same motion instruction to position register number 3. That's the position of the part on table number 2. It's going to be on the center of the table with an offset of position register number 5. Then we move to the place position, and I'm going to call the simulation program for the placing the part on table 2. We're going to wait, and we're going to go back to the perch position. Then I change again the user frame to number 0, and I move the robot to home. Other program, what I'm going to do, we're going to pick up the part from table 2 and put it back on table 1. So the motion is going to be very similar to what we have done on table 1 to table 2. That means that we're going to define the user frame number 2 for table 2, user tool number 1, the payload. We're going to go again to position register number 3, that is the part on table 2 with an offset of position register number 5. We're going to pick up the part. I'm going to call the simulation program. We're going to wait. We're going to go back up with the tool offset, and then we're going to call home with the user frame number 0 and home. And then what we need to do, we need to place the part on table 1. So I'm going to change the user frame to number 1. We're going to go to the perch position according to the position register number 2 that was already updated. Then we go to the place position. I call the simulation program for placing the part on table 1. We wait 100 milliseconds. We go to the perch position again, and then we go to home. And that's all that we have to do. You're going to notice that on these two TP programs, table 1 to table 2 and table 2 to table 1, the only thing that we are doing is using the position register number 2 that has been updated on the programs that we have for the KAREL program, that they are called on the, if we go back, they're going to be called on the main select position in line number 9 and line number 10. So now we're going to run the simulation and see what happened. What we need to do, we need to go to registers. We're going to select the number, the part that we want to pick up for table number 1. We are going to select this program, and then we're going to call the simulation here. So the program run and the robot just pick up part number 1. We can change this one. We can select any other part. Number 3. We're going to run it again. And this time it's going to take part number 3. We continue that, selecting the part that we want. Let's take another one, and we run it again. And this time it picked it up part number 12. If we go back to the KAREL programs, you will notice that there are some redundancies on the part data structure. I'm defining the structure data type, and I have in here the select part that is not used in this program. So now if we go back to the select part KAREL program, again I'm making reference to the part array that comes from the part data structure, and in here I'm using the variable select part. So what we can do, we can clean up this program and put everything together. Create a new program, and I'm going to call it select part version 2. And what I'm doing here, I'm just defining the user data type for the structure and defining the user-defined data type per array, and I'm defining all the variables in here, plus I'm creating a routine, and inside the routine I would have the same executed section that I had before in the part data structure. The only thing I have to do is, as on this section in here, I'm going to call the routine with the argument part. So now we can build the program. Everything else is exactly the same. And when we go to the program for the main select position, the only thing that we need to do, we need to comment out remark remark this line, because we don't need this one anymore. And instead of calling the select part KAREL program, we're gonna select the version number 2. That would be this one in here. And then you can run the program again and it'll be exactly the same. And with this, I conclude the presentation for this video.